So the next unit we're going to look at is on circles. So before we get too much further, let's get some information about circles and some terminology that we're going to be using so we know what's going on with this. Okay, so whoops, wrong tab. Let's go back to here. There we go. So what is a circle? Well, first of all, a circle is nothing more than a collection of points equidistant from one point. So when we talk about a circle, the circle is not the inside. The circle is the ring on the outside, because what makes the circle is every single point that's on this circle, okay? Not the stuff inside. Every point that's on here is the exact same distance away from a center point. That distance is called a radius. So the radius is the distance or segment sometimes from the center to a circle. Okay, so sometimes we say that the radius is the distance. Okay, the radius is 12 feet long. Sometimes we talk about the radius as being a segment. So it is a segment. The center is the point on a circle, or in a circle, I'm sorry, in a circle that all points come from or are equidistant. Can't spell today. Let's try it again. Equidistant to. Okay, so the center of our radius. We also name our circles by the center. So this would be circle A. They might actually write that as circle A, would be how we name that circle. Our radius, we might name it, since it's a segment, I might name it as radius AB, okay, because it's a segment. Congruent circles? Well, congruent circles are circles that have congruent radii. Okay, radii is just a plural of radius. So our Olympic rings are 5 congruent circles. They all have the same radius measurement. Concentric circles are circles that have the same center. When you look at a dartboard, these are concentric circles because they're all centered on the bullseye. So this circle, called our triple ring in darts, is one circle. Then we've got another circle here. Even the outside edge of the dartboard is another concentric circle. So that's what we mean by concentric circles. Circumference is the measurement, or we'll say the length around a circle. So circumference is how far it goes, how far it's actually around the circle. So you're talking in feet and inches, not degrees. When we talk about part of that, we talk about the arc. So the arc is the distance between 2 points on a circle. Okay, so if I put 2 points on the circle, there's an arc in here. There's an arc around there. There's an arc around here. In fact, there's an arc there as well. So there's a bunch of different arcs. If it's half the circle, we call that a semicircle. So this is the arc of half a circle. A minor arc is an arc of less than 180 degrees. We measure arcs in 2 ways. We can measure arcs in how long they are, or we can measure an arc by how much it opens. That's something we're going to talk about more. When we look at a minor arc, we can name that minor arc AB with an arc symbol over it. So that tells me it's arc AB. A major arc would be an arc of more than 180 degrees. Okay, so a major arc, here's the catch with the major arc. I can't call it FG. I need another letter here. Okay, because anytime you name a major arc, you have to use 3 letters. So if I wanted to call this major arc, I'd call it FHG. What that tells me is I'm going from F through H to G. If I just called it FG, it would be the minor arc FG. So be careful with that. Whenever you're naming a major arc, you have to use 3 letters. Okay, so that's the first set of definitions that we got. Let's take a look at some more information. I'm going to actually have you do some definition writing now. Okay, so what I want you to do is take a look at what makes a chord. We have chords here. All these segments are chords. And what does not make a chord, and make up your own definition. And then we'll come in and I'll give you another definition. Okay, so go ahead, take a moment, come up with a definition for a chord. Okay, so now that you've got a definition for a chord, we said that a chord, it's a segment, first of all. So a segment connecting 2 points on a circle. Okay, when I look at these pictures, R is not on the circle, so that's not a chord. Q is not on the circle, it's the center. PQ is a radius. Here, there's only 1 point. So these are all connecting 2 points on the circle. So that's what make a chord. And the key is it has to be a segment. VW, that's a line, not a segment. So chords have to be segments, can't be arcs. Try another one. Define, and this is one you might actually have defined in some ways before. Define diameter. Now, most people, after defining diameter, their answer is usually half a circle. Except that's not true. Half a circle is this. The diameter is going across. Some people define diameter as 2 radii, and that also is true. But in a real good definition of diameter, it's a chord through the center of a circle. That's what it is. It's a chord, just like the chords that we talked about before, but it's going through the center. Chord RS is not going through the center, so it doesn't count. WV doesn't make a chord. It doesn't reach to the other side of the circle. So it has to be a chord going through the center. Facts about it? Yes, it is twice the measurement of it is twice the radius. It does create a semicircle, but this would be our actual definition of it. So let's keep trying to do some of those definitions. Try making up another one. Here's one for you, a secant. Looking at these pictures, looking at what we have here, what makes a secant? Well, the first thing I notice about my secants, they're all lines, okay? Unlike chords, which are segments, the secants are all lines. This line here only hits 1 time. The secant goes through twice. So a secant is a line that passes through a circle 2 times, or it intersects the circle twice. Okay, so we have to hit the circle 2 times to make a secant. Okay, so let's look at a tangent then. Looking at a tangent, here's 3 tangents. Here's things that are not tangents. Write a definition. One thing you should notice about tangents, again, they're all lines. There's a segment, there's a ray, those are not tangents. The tangents are all lines. So it's a line that, and unlike the chord, it only intersects 1 time. Intersects a circle exactly once. Okay? Almost done with some of these. A few more. Just a couple more, I think. So number 5, an inscribed angle. Take a look at these angles that we have are inscribed angles and what they intercept, and these angles. So when I looked at the inscribed angle, notice that the vertex of each of these, A, B, C, there's B. B, C, D, there's C. C, D, E, there's D. The vertex is on the circle. Here we got a vertex off a circle, there the vertex at the center of the circle. Here my vertex is on the circle, but the other side of the angle is not in the circle. So it has to be an angle with a vertex on the circle that intercepts an arc with the rays. So in this case, this intercepts once, but we still get an arc here, but this other ray doesn't actually get to the circle. So you have to be able to have 3 points of the angle on the circle. That's a good way to look at it. 3 points of the angle, 3 points of the angle. That's what makes it inscribed. The term inscribed, we've talked about before, drawn inside. So we have to make sure that this angle is drawn inside. One more type of angle, what we call a central angle. So give me your definition of a central angle. Well, again, notice our central angle is inside the circle, but notice where the center is. The center of a central angle is centered at the center of the circle. So it's an angle with the vertex at the center of the circle. Okay, so there are some terms that we need to know for circles. We're going to be using these throughout our next unit, so make sure you learn exactly what they are and can recognize them. Okay, have a nice night. We'll see you next class.